when we understand what is work, power, and energy, okay, work, power, and energy. So, this is the basic chapter that we have to do.
Mm-hmm.
All right. Now, what are we going to do in work, power, energy? Just understand. When we are talking about the work, power, energy, there are a few terms that you have to understand. The very first thing is there is a term called force. What is force? Force is a kind of push or a pull. Force is a kind of push or a pull. That means if this is going to be an object, so you can push it along the green force, F1. You can push it along the red force, along F2. You can push it along the force 3, which is the blue force. You can push it along the F4 force. You could push it along the F5 force and so on. Are you understanding?
Mm-hmm.
So when we are talking about the work, power, and energy, it means what? It means what? That there is a mass M. Okay? And this mass M, when we are forcing it, when we are pushing it, so definitely this mass shall move. But which force do you think can move this mass? Do you think force F1 can move this mass? Do you think force F3 can move this mass?
Mm-hmm.
Do you think that force F4 can move this mass? Do you think that force F5 can move this mass? Yes.
Yes.
But force F2 cannot move this mass because it is good. It can just push the body downwards. Are you
Yes.
understanding my point?
Mm-hmm.
So we are saying that force can be applied in any direction. Force can be applied in any direction. Do you understand my point?
Yes.
And force can be applied in any direction. What does that mean? That that it has a particular direction. Are you
Mm-hmm.
understanding my point?
Yes.
So when it can be applied in any direction, what exactly do you think it means? That ma'am, force has a direction and a magnitude.
Yes.
And a magnitude. Do you understand?
Mm-hmm.
And when it has a magnitude, what exactly do you think it means? When it has a magnitude, what exactly do you think it means? Magnitude means that ma'am, on this box of mass M, I have applied a force of 10 newtons.
Yes.
On this box of mass M, I have applied a force of 20 newtons. So, newtons is the unit of force.
Force. Okay.
Newtons is the unit of force. And 20 is the magnitude. 20 is the magnitude. Do you understand my point?
Mm-hmm.
Any doubts in this?
No.
So, when we are talking about the magnitude, okay, 10 is the magnitude. So, greater the magnitude, greater the force.
Mm-hmm.
Lesser the magnitude, lesser the force. Very simple.
Yes.
So, this force, what am I going to say? Let us suppose this is force F1, which is of 10 newtons. So, what would you say? F1 force is 10 newtons, and that F1 force is going to push this mass forward. So, that force is being applied due east. Yes or no? That force is being applied due east. Any doubts in this?
No.
And this force F2, which is of 20 newtons, is applied due west. So, there is a direction as well.
Mm-hmm.
So, in defining a force, you have to tell that it is a push or a pull. It is a push or a pull, and it has a magnitude as well as a direction. Do you understand?
Yes.
And when it has a direction as well as a magnitude, that means what? That means it is a vector quantity. Force is a
Right.
vector quantity. Yes or no?
Yes.
So one term is force. Now understand. When we talk about this box, we say, okay, this box is 10 kgs, and I have applied a force on this box of 50 newtons. So this is the force. So unit of force is Newton. So from the unit, you can identify what is being given to you. Do you understand my point?
Mm-hmm.
And this box is going to move forward. This box is going to move forward. Obviously, when you're pushing it forward, it is going to move forward.
Yes.
And when it is going to move forward, it is going to move, let's suppose, 20 meters forward. Do you understand?
Mm-hmm.
So this is the displacement that this body M is doing or taking in the presence of the force 50 newtons. So this is the displacement.
Okay.
So I'm going to say that this force has done some work. So when according to physics the work is said to be done, work is said to be done, work is said to be done when when a force of when a force is applied, when a force is applied on a body, when a force is applied on the body and the body travels a certain distance, and the body travels a certain distance. Yes or no?
Mm-hmm. Mm-hmm.
So this is called displacement. Yes or no?
Yes.
So this is what you understand by the term work. So how do I define work? How do I define work? Work is actually when you apply a force and the body travels a certain displacement. So force times displacement gives me work. That's a very, very simple formula and definition of work. So a very simple formula and a definition of work would be what? That work is equals to force times
Times
displacement.
displacement.
Yes or no?
Yes. Yes.
All right. So what is the unit of force? Newtons.
Mm-hmm.
What is the unit of displacement? Meters.
Meters.
So unit of work shall be Newton into meters.
Yes.
Newton into meters.
Meters.
Understood? And that means what? And that means what? You tell me. Newton into meters.
Mm-hmm.
And that is called 1 joules.
One, two,
And that is called 1 joules. Yes
one,
or
two.
no?
Yes.
So that is the concept. All right.
Yes.
So let's suppose in what all conditions can you say the work is being done? Now understand. Now let us suppose this is the box. And let's suppose you're applying certain force here. Let's suppose you're saying I am applying 100 newtons of force on 5 kgs. So definitely if this box move forward and the box, so here what is happening, what I'm trying to explain you here is that the displacement is also forward and the
Yes.
force is also forward. Are you understanding? So let's
Mm-hmm.
suppose the displacement is 6 meters. So what do you think should be? Work is equals to force into displacement.
Yes.
That's the formula. So your books shall write down F into S. That shall be the work done.
Mm-hmm.
You understand?
Yes.
So work is equals to force into displacement. So my point is that if you're applying a force of 100 newtons and this moves 6 meters, in this particular example, the force and the displacement both are forward. So what is the angle between force and displacement? What is the angle between force and displacement? 0 degrees.
Mm-hmm.
Yes or no?
Yes.
So I would say work is equals to force is 100 newtons, displacement is 6 meters, and the work shall be 600
Juice.
joules. A very, very simple question. That means, ma'am, if the body has moved a certain distance, only then we can say that the body has done some work.
Yes.
But here, understand the direction of the force and displacement are both in the same direction.
Mm-hmm.
Do you understand my point?
Yes.
So here the angle in this case, whenever you get to see this kind of situation, the angle between the force and displacement shall be 0 degrees. Understood or no?
Mm-hmm.
Alright, now, but not every time this is the case. What exactly happens is this. Let's suppose we have this box. Let's suppose we have this box and we have this another box. Basically, both of them are the same box. But this box of, let's suppose, 5 kgs, this box of 5 kgs, okay? For this particular box of 5 kgs, let's suppose I am, pulling it like this. I have
Mm-hmm.
tied a thread to this box and I am pulling it at an angular distance. But this box is going to move forward. There are a lot of cases where you pull something, angularly and it moves forward, isn't it?
Yes.
In that scenario, what is happening? There is an angle being there between the force and the displacement. Do you understand my point?
Mm-hmm.
So, between the force and the displacement, what is happening? There is a particular angle.
Angle.
So, then the formula of work is going to be what? That, ma'am, in this example also, you are applying force and the body is moving some distance.
Mm-hmm.
So, when you're applying force and the body is moving a certain distance, what do you think would happen? Tell me. That, ma'am, work is
Well,
being done because that's the definition of work.
yeah, it is doing work.
Why am I saying that? Because when you apply certain force and the body travels a distance, that's
Yes.
the basic meaning of work according to physics.
Yes.
So work would be what? Fs. Now the new formula here would be, but sometimes I'm saying that sometimes 99% times what happens is we have the force and the displacement being in the same direction.
Okay.
But sometimes what exactly happens is that force and displacement are not in the same direction. They are at a
Mm-hmm.
certain angle. Force is here at the top and displacement is forward. Do you understand my point?
Yes.
So work is going to be force times displacement, isn't it?
Mm-hmm.
What does that mean? That work is going to be Fs cos theta. So the new formula for work will be Fs cos theta. And what is theta?
Because it's
Theta
going
is
up.
the
Okay.
exactly. Theta is the angle between force and displacement.
Yes.
Understood or not?
Yes.
So you write down the values. If you have cos 0 degrees, theta is an angle. So cos 0 degrees is 1. Cos 30 degrees is going to be root 3 over 2. Cos 45 degrees is going to be 1 over root 2. Cos 60 degrees is going to be cos 60 degrees is going to be 1 over 2. And cos 90 degrees is going to be 0 degrees. Is going to be 0. Cos 180 degrees is going to be minus 1. So what I'm trying to tell you is that whatever is the angle being formed, accordingly you can put in the value and you can find out the value of the work done. So you understand that force is a vector quantity, displacement is also a vector quantity,
Mm-hmm.
and the two vectors cos theta. That means, can I say work is equals to force is a vector, Fs cos theta? Don't you think it is going to look like A B cos theta?
Yes, it'd be.
Isn't it?
Mm-hmm.
And if it looks like A B cos theta, what exactly does that mean? If it looks like A B cos theta, what do you think it is going to be?
So
Fs cos theta.
theta. Yeah.
So it is actually looking like a dot product of two vectors.
Mm-hmm.
It is looking like a dot product of two vectors, isn't it? That means what? That means what? Tell me.
So it would
That
also do
means
the
work
same.
is a scalar quantity
Yeah,
because
that
the
would mean that
dot product of two vectors,
is
the dot
scalar.
product of two vectors is a scalar quantity. Yes or no?
Mm-hmm.
That is a concept. So work is a scalar quantity. Understood or not?
Yes.
All right. So it is going to be f cos theta you write down. So the question arises that how can you conclude that work is a scalar quantity? So you will say that work is a scalar quantity because it is the dot product of two vectors. Because when you elaborate f dot s, it is going to be f s cos theta. That is my work done, and hence it is a vector. Hence it is a scalar quantity.
Mm-hmm.
Yes or no?
Yes.
All right. Any doubts in this?
No.
So that is the concept. So when I give you these kind of questions, let's suppose I give you this. Let's suppose I give you this. Now understand, work could be of different situations. You know, work can be positive, work can be positive, work can be negative, and work can be zero. Now, when can the work be positive? When can the work be negative? And when can the work be zero? Now, understand one example. Let us suppose there is this person, okay? And this person is moving how? This person is actually moving forward. And he has this box M placed on his head and he's moving forward.
Um,
Now, when he's moving forward, you tell me what exactly is happening. Don't you think that this man, to hold this box, don't you think this person has sort of, applied force upwards? Because obviously, only then he will be able to pick up the box, isn't it?
yes.
So, when he will be able to pick up the box, what exactly do you think would happen? Tell me.
Hmm?
What do you think would happen? This box would do what? Tell me. This box,
Um,
the person is moving forward, isn't it? So, when
yes.
the person moves and comes here, what do you think would happen?
Well, the box will also
The box has moved up forward.
move forward. Yes.
So the displacement of the box is forward, no doubt.
It's changed. Yes.
But do you see somebody pushing him forward? No.
No.
Nobody is pushing the box forward. The box is being pushed upwards. Why? In order to hold the box at the top of the body,
Mm-hmm.
isn't it?
Yes.
What I'm trying to tell you here is that the force here is upward, but the displacement is forward.
Yes.
And when this is happening, what is the angle between force and displacement?
But this forms like a right angle, so this should be the 90 degrees.
90 degrees. So now in this example, let's suppose I say that the person is pushing the box upwards with the force of 10 newtons. and we have moved forward 6 meters. So what do you think should the work be? Work should be Fs cos theta.
Yes.
So force is 10, S is 6 cos 90.
S is 6.
So cos 90 is 0. So no matter how much force you have applied, no matter how much you have displaced, the cos 90 is 0. So work done should be 0.
Right.
So according to physics, you have done basically no work, because you are not doing work in moving this body forward. You're doing no work in moving this body forward. Do you understand my point?
Okay. Yeah.
Any
Yes.
doubts in this?
No.
So the work can be 0. Wherever the angle between the force and the displacement is 90 degrees, the work can be 0. Yes or no?
Mm-hmm.
That is the concept. So whenever we are talking about this, the work done can be positive, work done can be negative, and work done can be 0. Now understand? Let's suppose we say, right? And if suppose, just have a look at the values. So cos 0 is going to be 1, cos 30 degrees is going to be root 3 over 2, cos 45 is going to be 1 over root 2, cos 60 is going to be root 1 over 2, cos 90 is going to be 0. So 0 work done comes up when the theta is 90,
Yes.
right? And cos just after 90 to 180, whatever is the angle, cos theta shall be negative. You just see the value of cos 180. Cos 180 value is minus 1. Cos 135 value shall be minus 1 over root 2. Cos 150 degrees shall be what? Minus root 3 over 2. And cos 120 degrees shall be minus 1 over 2. Are you understanding my point?
Yes.
So my point is that if we have these particular values, now let's suppose this is happening. Let's suppose the body is forward, moving forward, and we are pulling the body here. You understand my point? Understand?
Mm-hmm.
So my point here is going to be what, that displacement and force, they have an angle of some obtuse angle here. What is obtuse angle? Greater than 90 but not exactly 180.
Yes.
So you just have a look at those values, cos 135, cos 150, cos 120. Don't you think all these values are negative? So if I say the
Yes.
force being applied is 100 newtons and the displacement is 5 meters. So do you understand that work should be what? Aditi, tell me. What do you think the work should be? Work should be what?
The
Force
F
times
times
displacement 1 cos theta.
cos theta. Yes.
So work should be what? Force is going to be
100.
100. Displacement is 5 meters, but cos theta, let's suppose I take in 120. So when you put
Yes.
cos 120, so it is going to become 500 into cos 120. What is cos 120? Minus 1 by 2.
Minus 1. Yes.
So
That's
it
right.
becomes 250. So work done shall be 250 joules.
Yes.
Yes or no?
But it's
Negative.
negative, correct? Yeah.
That means work can be negative.
Okay.
So in under what conditions can the work be negative? Whenever
In
the
the
angle is
obtuse.
exactly. Do you understand my point?
Yes.
That is the concept. Any doubt on this? Just tell me that.
No.
All right. This is the concept. Any doubts up till this?
No.
All right. So work done can be negative. Work done can be 0. And work done definitely is positive on all these values up till when the angle is less than 90.
Hmm.
Any doubts in this?
No.
Are you sure? So this is the total explanation of work done. So all you have to remember is that when theta is 90, when theta is obtuse, and when theta is acute, under different conditions, work done can be positive, negative, as well as 0. Work done is a work done is a scalar quantity. Why? Because it is a dot product of two vectors, and the dot product of two vectors shall give me scalar. Right, Aditi?